Hello, my name is Mira, and my group decided to find a product for patients who have paralysis. In this video, I'll be discussing the current technology used and the technology that we'll be trying to produce. I'll also discuss the individual design. So, individual solution. This product is called BCI, or Brain Computer Interface. The current solution is a cap that connects to the synapses, but this technology is currently very bulky and heavy, and it causes a lot of discomfort for the patient. The current BCA doesn't give accurate response times or give results on time. For our solution, we want to make something that is less bulkier and lightweight so the person using it doesn't have any discomfort. So the current brain-computer interface looks like this. It's usually white and it connects to synapses within the brain, and it's connected to wires which then connect to a computer, and it shows the results in the computer, but usually there isn't accurate results, and sometimes it takes a very long time for results to come up on the computer. So um, the designs that we're going to be talking about in this video, they're going to be more accurate. Okay. The first solution is a lightweight cap, and this will do something very similar to the current BCI technology, but it will be less bulkier and a smaller size than the current device. The cap will also be in different colors, so it can go with different outfits. This device will be working with pre-existing nervous system. The cost of this will be inexpensive, so the manufacturing and assembling of the product will also be inexpensive. It will be installed very easily, so the patient using the cap won't have any discomfort. The product will also be dust-proof and water-resistant for 30 minutes. So this drawing is very horrible, and I am very sorry, but it will look very similar to the individual solution to the current BCI technology. The only difference is that it will be less bulkier and less of a discomfort for the patient using it. It will also come in separate colors. Um, okay, so the second solution, which is an individual solution, is a small implant into the spine, and it can do it will do similar processes that the cap does. The only difference is that the cap is on the head, on the body, and it can be taken off, but the implant will be within the body and won't be taken off like a cap. The implant is very small and will go inside the top of the spine and connect to the synapses in the brain. So the implant will go between the brain and the spine. So it's easier for the implant to connect to the nervous system, which will then help with connecting the nervous system to the patient's limbs, and they will have more control over their limbs. It will give quick results and won't be of any discomfort for the person using it. The cost for this implant is a bit on the higher side, considering the materials that will be used and the surgery that will take place to insert the implant. The product will be durable, and considering the materials that will be used and how long the implant will be in the body. So the big difference between the cap and the implant is that it will be much more expensive. This next slide we'll be talking about the criteria. So the criteria for both solutions were divided into four different things: cost, safety, durability, and functionality. The numbers represent how important that criteria is to its respective product. The numbers are from a scale of 1 to 10, 10 being most important and 1 being least important. Each criteria represents a factor to the product that's important for the product to have successful results. The cost for the individual solution is least important, but the safety is more important compared to the group solution, where the cost is more important while the safety is a little bit less important. And that is